Hey everyone, I realized that I didn't post a video that went with today's lesson. It's similar to yesterday's lesson. The only difference is rather than looking at a rectangular prism or a cube, you're looking at a triangular prism. And what that's comprised of are two faces that are triangles. Those two sides are parallel to one another, okay? So in the three examples that we have today, in the first two, it's the front and the back that are your triangles. And remember, that's a base times height divided by 2 to find out the area of one of those faces. You then have what are called lateral faces, the sides, okay? There are 3 of them. On all triangular prisms, there are 3. And those are rectangles, okay? So what I have here in red are the 2 lateral faces that are coming up this way. Think of it kind of like a tent, okay? And then there's one along the bottom. It's breaking apart because this isn't an equilateral triangle. Given the fact that our triangles can all be different, equilateral, isosceles, or scalene, the area of those lateral faces can be different. Okay, so it's really important not to just assume that all 3, it would have looked like this without that front and back face, okay? That all 3 are not necessarily the same. They're all going to be a length times width to figure out the sides, okay? But they're all not necessarily all exactly the same. Okay, so either way, I'll be on at 2 o'clock to go over those 3 different examples. You'll notice that on question 11, it's kind of like whited out and it just says 5 millimeters. That's because it was a decimal and I changed it for you guys. You're welcome. But either way, I will see you guys at 2 and we will go over these together, okay? Keep in mind, all of these are 5 faces. You should be adding 5 numbers together to get that total surface area. I'll see you guys at 2.